Hello, good evening everyone. Welcome you all to this course, Solar Energy Engineering and Technology. This is live session 7 being taken by Rohit. I'm a POS scholar at IIT Bombay. So I assume that you guys have gone through the lecture videos. I think someone wants to join. Let's see who wants to join for this week. So, sir, can you do question 11, 12 model for this week? Rajeshwari, we can't do question 11, 12 because we have been strictly forbidden to go through the current week assignment questions. Okay, so yeah, we will go through those type of questions. I don't know what was in question 11 and 12. I haven't gone through the questions also. So let's see. But the exact question I can't discuss in this course because it will give you guys an undue advantage over others. Okay. What? Okay, so you want that key like 11 and 12, can you do a model question? Okay, but okay, I will see. Let me check what are the question 11 and 12. So, okay, let me check what are the questions. Yes, Rajeshwari. 313. Wait. Let me share my screen. I'm still not sure which question are you talking about. So which question are you talking about? 9? Is this the question? This week 7. Week 7 question I can't solve here, Rajeshwari. We are strictly forbidden. Air is flowing between two parallel plates separated by 1 inch with an inclination of 30 degree. Consider the properties of air. Thermal conductivity is given, velocity is given, viscosity is given, alpha is given. Okay, if the temperature hot and cold plates are respectively, then convective heat transfer coefficient between the plates. So what is the problem in this question? I still can't figure out. What is 30 degree? See, if there is a angle of incidence of 30 degree on the observer plate, like there are two plates and each has a 30 degree. So consider it na 30-degree inclined, make it inclined. Okay, so the forces will be actually inclined. So you can take a component of those forces. And what are the 11 12 water flows at a velocity of tube which the mean temperature of water and tube are at isothermal condition. This and this. Okay, and properties are given. Heat transfer. These are very simple question. Your Prandtl number is given. So Prandtl number is equal to just find a relation between Prandtl number and K. All these things. Okay. So generally Prandtl number is mu Cp upon K. So you can get mu from here. You know the water the density of water is 1000 kg per meter cube. So you can get the mu from here. K is given. You can get the Cp. After getting the Cp, you can calculate the temperatures are given. Everything is given. The heat transfer coefficient only you have to calculate. The rate of heat transfer will also be calculated. So I think there is a relation between this Prandtl number and heat transfer coefficient also. It something related with Nusselt number or something for a tube diameter pipe. So that you can also use. Please go through the slides. The questions are already mentioned there. Means the formula which is to be used is already mentioned there. You can easily solve these questions. These questions are not so hard question. Just keep calm, note down the important things which are given, and then try to solve it. Okay, you will be able to solve it. Don't worry. Okay, I should. What should I do? Should I solve it? Otherwise, arey yaar, if somebody complains, then that will be a good problem. So, what I will do? Should I give you a hint? You guys need hint. You guys need hint for this. And then the NPTEL guys will kill me then. Okay. See, I will give you a hint. Okay. So what do you say for inclined question? Which I will give a hint for one question. The inclined question, question number 9 or question number 11 or 12. Which one you want? 11. This one. Arey, this one is very easy. Inclined question could अच्छा ठीक. Okay. Okay. So everything is given. You just need to have a. So do one thing. First, observe the data. So you have given velocity. Write down what I am saying. Write down. You have given velocity 3.2 meter per second and tube diameter at 2 inch. So convert tube diameter into meter. So how many meter will be inch? 1 inch equal to 2.54 centimeter. So convert 2 inches into meter. Okay. So is that okay? And the length is 10 meter long. So you have got length, you have got diameter, you have got the velocity. So what is the property that links velocity, length and diameter all into a single term? Think which property? Which number? Do you remember something called Reynolds number? Say yes or no, so I can give you guys a. No, you don't know because you haven't gone through the slides. Okay, Rajeshwari, go through the slides, open the slides, at least go through them at least once. So these questions will easily be solved from them. So okay, I will give you a hint. Okay, Reynolds number is there. So you can calculate Reynolds number. And what is Reynolds number? Reynolds number is velocity multiplied by diameter, okay, upon the value of mu. That is kinematic viscosity. So you can get the Reynolds number. So the Reynolds will be number will be something, a number will be there. Okay. So after obtaining the Reynolds number, do one thing. There is mean temperature on tube wall as given. So get a mean temperature, like a average temperature. So you can calculate the average temperature from these two. Okay. So after getting the average temperature and Reynolds number, now you know the Dietius-Boultier equation. So Dietius-Boultier equation, you know, Nusselt number, the relation between Nusselt number and Reynolds number and Prandtl number. So write down. Get the relation for Dietius-Boultier equation. Okay. So from there, you know the Reynolds number, you know the Prandtl number. So you will get the Nusselt number from there. And Nusselt number equal to HD upon K. So you know the diameter, you know the K value, thermal conductivity value, and what is needed? Heat transfer coefficient. So you can get the heat transfer coefficient H value. Rajeshwari, can you get the heat transfer coefficient value, or if you could not understand, I will repeat it again, or the portion you don't understand, please ask me. I will repeat it again. You understand? So what did I say? Repeat. How to solve this question? Somebody wants to join. Ragini wants to join. Okay. So what is it? Rajeshwari, don't panic. It's okay. It's okay if you can't solve it. Many people can't solve it. It's okay. So don't be what you say. Don't be so nervous. Everything is okay. So if you can't solve it, just because you haven't practiced this question, that's why you can't solve it. So if you practice more question like this, you will be easily able to solve it. Okay, and don't worry, don't panic. Just open the slides. There are lots of formulas given. Okay, so we call it formulas, but they are actually empirical relation. So try to see these questions, which of these formulas can fit into these data. So the most easiest thing which you can do is to check whether which one of the formulas is actually fitted with this data. This is the simple way to solve a numerical question. I am saying simple way, but simple way doesn't mean the correct way. Okay, first you have to understand the question. What is the requirement of question? Okay, and what are the data given in the question. Once you have the data given in the question, once you know what are the requirements of the question, like here the requirement is to calculate the heat transfer coefficient. The units are also given, all the units are given. The units which are not in SI, like inch, so you have to convert it to meter. Okay, so now say what I have taught you just now. How will you solve this question? Anyone from the audience who wants to say how to approach this question? Let me see who is there. Who is there in the audience? Netik, can you? You haven't tried. Okay. Kavita, Nishit, Ragini. No one. Okay, so Rajeshwari is confused. Okay, let me tell you once again, Rajeshwari. Okay, don't be confused, don't panic. Okay, so you have given a velocity 3.2 meter per second. You have given a diameter 2 inches. you have given a length 10-meter long. Okay, so all these data are in meter, but this is in inches. So you convert it to meter. So go to Google, write how many meters are 2 inches. So that will give you the data. So simplest thing. Okay. Next thing is mean temperature of water and tube wall is given. So do one thing, take a average of 300 Kelvin plus 348 Kelvin upon 2. So that will give you in Kelvin. So convert it to Celsius. Done. Next thing is calculate the Reynolds number, that is mu d, sorry, Reynolds number is this velocity u into d diameter upon this mu value, kinematic viscosity. So that will give you a Reynolds number. Now you have Ditus-Boultier equation that says mu or मतलब Nusselt number equal to 0.023 into Reynolds power 0.8 into Prandtl number power 0.4. Done. Put the values, Reynolds number value you have calculated, Prandtl number value you have got from here. So put those values, you will get a Nusselt number value. After getting the Nusselt number value, Nusselt number equal to H into D upon K. So you know the diameter D from here, you know the K from here, thermal conductivity. So what you don't know H. So you know the Nusselt number. Just calculate the value of H. Okay. So is that okay? Understood? Will you be able to do it? Okay, so Rajeshwari, I will see you don't do wrong this question because I have given a pretty good amount of time to just to make sure you have understood this question. Okay, so I'm sure you will be able to do it. Otherwise, if you are not able to understand any question, so if you are not able to understand any question, so go here, ask a question. I think you can post this question by clicking new conversation here. You can ask your question here. Okay, so that will be here. So I think you will see it's very helpful if you update a detailed solution of the. I think solution and detailed solution are given maybe after the course, or I don't know. Many of these questions have actually been asked here. Reliability questions related to last week assignments. The TA seems to be not so active. These are not. Okay, questions related to live session also you can post it here. So I am basically a live session TA, so I can answer those live session question. Okay, these questions are for the regular TAs and the professor to answer. Okay. See. This relation is also given here. You don't have to go to slides also. What I was saying, no cell number is related to Reynolds number, Prandtl number. Na? See here. So you have got the Reynolds number, put it here. You have got the Prandtl number. Prandtl, how much is the Prandtl number? 2.98. Put it here. So you will get the Nusselt number, and Nusselt number equal to HD upon K. So put the value of diameter, put the value of thermal conductivity. You will get the value of H, which is heat transfer coefficient. So is that okay? Mm-hmm. Okay. So I think I will let you guys with this question. So please solve this question. I will give you guys 5 or 10 minutes, whatever minute you demand. Please solve this question, and then we will discuss the next question. Okay. Please solve this question and try to find out how much is the answer for heat transfer coefficient. Okay. So time starts now, ticking. Solve it soon. The question 11, solve it and tell me how much is the answer. Okay, no one got the answer. Try, guys. It's so simple. So, do you still need time or should I move on? Rajeshwari, are you solving the question or should I move to some other slide or discuss some other question? Nishit is saying please move on. Okay, okay. So I will leave this question to you guys. Please solve it. Okay. So I am sure you will be able to solve it. So don't worry about this question. These are very typical questions which can easily be solved with the concept discussed in the slide. So what I will do, I will go through the slides. Okay, I have prepared my slide. I won't discuss the theory part here. I will try to discuss only the questions. So most of the question are like this only. So I think that will help you guys also. And I will make sure you guys solve those questions. Okay, so because if you guys don't solve those questions, then it doesn't matter whatever I teach. It will not be able to help you guys. Okay, so okay, let's start. So let me. Okay, so let me try some questions from previous run of this course. So, yeah, let's solve the assignment question itself. So the first question is ratio of energy actually absorbed and transferred to the heat transfer fluid by collector to the energy incident on the collector is called as. So first thing, let me draw. So let's say this is something called solar collector. Mark it as S. Okay. So it has some energy from sun incident on it and it will give some energy. Okay. So input, output. So what is it saying? The ratio of energy actually absorbed and transferred to heat transfer fluid by collector, that is absorbed and transferred to heat transfer fluid. So energy output uh, in the form of absorbed plus transfer to heat transfer fluid to the energy incident on the collector is called as, it's called as collector efficiency. Okay, why collector efficiency? Because it is the efficiency of the collector which is depicting by this output over input. It's not the absorber efficiency, it's not the transmittive absorptive product or overall efficiency, it's the collector efficiency. Correct? Moving to question 2. IB and ID are amount of beam and diffuse radiation respectively, then the amount of incident solar flux absorbed in the absorber plate can be expressed as. So yeah, there is absorber plate. IB and ID are the beam and diffuse radiation. So basically when you go through different components and try to compile them, so you will find even in the slides it has been given. So you will find this is the correct answer. Okay, so amount of incident solar flux absorbed in the absorbed light will be this much. Okay, when the fluid is cooled under forced convection mode of heat transfer, the heat transfer coefficient can be calculated using the expression Nu equal to 0.023 Re to the power 0.8 and Prandtl number to the power point. So this formula is DTS-Boelter equation, and for this the Prandtl number n equal to zero point 0.3. Okay, so the correct answer is 0.3. So this is very important expression, very important. Let me write it down. Please note it down. If you haven't gone through this equation, please note it down and remember it. And please see, have a look at this equation. Think of the questions which you have tried and could not be able to solve it. So think whether the data which is given in the equation actually fits with this equation. Can you solve those questions with this equation? Try to think, okay? And inform me if you are able to solve those questions. Okay, so were you guys able to adapt this question and solve the questions discussed previously? So let's move to the next question now. In case of solar flat plate collectors, the useful heat gain would become zero when the absorber plate attains. So actually the heat gain, what will happen? So they in case of solar flat plate collectors, so the temperature will increase. Okay. So heat gain will be there, heat gain will be there because there will be temperature difference. But when there will be a stagnation temperature, so what will happen? The heat gain will be zero, no heat gain because the temperature has become stagnant, no increase in temperature. Okay, so option C is correct here. Transmissivity based on the reflection is obtained by. So it's not Bogus law, it's not Kirchhoff's law, it's not Newton's law of cooling. What is Newton's law of cooling? HA del T. Okay. No, Kirchhoff's law alpha equal to epsilon. I don't remember the Bogus law. It's because of Snell's law. Okay. The value of extinction coefficient for glass, which is used as cover material for solar thermal. So you know that so for solar thermal when these are the five solar thermal, etc. or maybe others. So the value of extinction coefficient for glass generally varies between 4 to 25 per meter. In dash type absorber plate design, high weighted area and liquid capacity is maintained in order to achieve moderate temperature, warming of swimming pool. Okay. So basically in rectangular and cylindrical full sandwich type absorber plate design, this happens. Okay. Now there is a question. So this is a similar question to what has been discussed or what has been asked in question 11. So I will solve this question in front of you. So before I solve this question, I want you guys to perfectly understand this question and note down the important data points which has been provided in this question. Okay, so I will give you guys 5 to 7 minutes to solve this question. Otherwise, I will solve it and try to tell me what should be the answer of this question. Okay, so please amount of time solve this question. Don't panic. The concepts have already been discussed. Please apply those concepts and solve this question. So should I solve it? What do you say? Okay, let me solve it then. Let me solve it. So first thing is velocity equal to 2 meter per second. Kinematic viscosity equal to 0.413 to 10 to the power minus 6. Okay, L is given 6 meter. T equal to 58. T mean equal to 58. Okay, so You write all these terms here. Now everything is known here. This is known, 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 known. What is unknown? H. That is being asked, the heat transfer coefficient. So calculate H to be after putting all those values and calculation. It's 8969 point something. Okay, so the correct answer is answer D. So please have a look at this question and try to see how this has been done. Okay, so I think most of you have got this question. So moving to the next question, the rate of heat transfer will be. So actually, when you have got this heat H value, so rate of heat transfer will be Q equal to H into A into del T. Now what is A? A equal to pi D into L. You know pi value, D value, and L value, and del T is here it's given. Okay, 82 and 58. So del T is the difference between these two. So H value you have got 8969.095 095 into pi into D 0.0508. L is 6 meter and delta is 82 minus 58. And since it is asking kilowatt, divided by 1000. So the correct answer will come at 206.15 kilowatt. So you guys can see how easily these questions are solved. So that's why I'm trying to solve each and every question. So most of the current assignment question will be aligned to these type of questions. So you can easily approach this question. So you don't have to panic. You don't have to put much more effort. Just try to understand the question, what the question is talking, what is required. Okay. So please have a look at this question, and then we will go to next question. पता नहीं, चांस तो कम लग रहा है। आई कांट से ब्रो। तुम्हें क्या काम था? रिपोर्ट पे साइन कराने हैं? कब है एपीएस? तो तुम दिया नहीं अभी तुमने रिपोर्ट? कौन है तुम्हारे कम? और वामसी सर? अरे रिपोर्ट दे दो यार, 3 दिन पहले रिपोर्ट दो, बहुत सुनोगे। साइन करा के दे दो, कल सबसे पहले सर आएंगे तो साइन करा के दे देना। सर ने क्या रिपोर्ट पे साइन नहीं कर रहे हैं क्या सर? तो अच्छा। ठीक है, और क्या। एंजॉय करो, कोई बात नहीं। 12 से 14 मतलब कल नहीं है कर्मा सर, तो रिपोर्ट दोगे कैसे? उनको सॉफ्ट कॉपी मेल कर देना। Okay, so should I move to the next question now? So it's saying a steel rod of 2.6 centimeter diameter is to be heated from this to this. They place concentrically in a long cylindrical furnace which has inside dia of 20 centimeter. Inner surface of the furnace is this, has an emissivity of 0.9. If the surface of the rod has an emissivity of 0.4, then the average rate of heat absorption during the process. So let's solve this question. So D rod is given 2.65. So first thing, how you approach this question is to write down all the data which is given. T R1 is given 380. T R2 is given 640. Okay, so convert them to Kelvin. So this will be 653 Kelvin, and this will be 913 Kelvin. Next thing is you need to know the inside dia, that is 20 centimeter, 0.02 meter is given. And this is, sorry, 0.2, not 0.2. This is 0.026. Ti is given 1050, converted to Kelvin, that is 1323. Epsilon surface of rod is given, that is for epsilon furnace is given 0.9, epsilon rod is given 0.54. Now you need to know the Q average and you have the data. So first thing is you have to obtain the safe factor. So for that you need to know the area of rod upon area of furnace. Okay, so put the values, get the data. Now after you know the safe factor, you need to calculate the view factor. So for view factor, you can use this formula, 1 upon epsilon, epsilon, that is R, epsilon of rod, plus this one, this ratio, put it here, into 1 upon epsilon of this furnace. Sorry, F, this is F, this is R, minus 1. So get the view factor. Now if you have the view factor, now you need to evaluate the initial rate of heat absorption. QIN I am terming it. So it's sigma A1, that is sigma, you know, 5.67 into 10 to the power minus 8. A1 you need to calculate point into 2.64, that is the area of rod, into epsilon 1 to 2, that is view factor calculated here, Ti4 minus T24. Okay, so that is this is T2 and this is T1. Okay, no, this is T1 actually, sorry, this one. Okay, so you get a value. Now you need to evaluate the rate of heat transfer just near the end of the rod, where the rod is actually getting to end. Okay, so at that place use the same formula, sigma A into epsilon 1 to Te4 minus T24. Okay, with this value you will get some data. Now another thing is that key you need to calculate the Q average. So that will be QIN plus QR upon 2, that will be average. Okay, so with this, putting the values, you will get the answer as 6640.05. I hope you will be able to solve this question. You guys could understand this question? I guess you guys have a good idea about solving the questions. Now there is a question on inclination. Okay, so let me solve this also for you guys. So, so this is basically a flat plate collector is made up of tube fastened on the side of absorber plate, two glass covers are placed above the absorber plate. Okay. Refracting index of glass relative to air is 1.53, angle of incidence is 35, thickness of each cover is 6 mm. So this is basically like this. What's happening here? These are the reflectivities. Okay. So depending on this, you can get the transmittivity value also. Okay. So I think none of these matches with the option. No? I think this one is pretty close. Yeah. This can be marked as. But the correct answer is this. Okay. So with this, I think these has to be solved by yourself. So thank you all for attending this live session, and it was a pretty much interesting to have you guys talk to the question and discuss your questions also. So we will meet again in the next week on Monday from 7 to 9 p.m. So if there are any questions, please write to me at this email address. Thank you all. Thank you for attending this live session.